and welcome to the first of a suite of talks jointly hosted by AerOx, the Oxford Aeronautical Society, and by Warwick Aerospace. Tonight we have the pleasure of being joined by Dr. Moriba Jah. Moriba Jah is an Associate Professor of Aerospace Engineering at the University of Texas, Austin, where he's Director of Computational, Astronautical Sciences and Technologies, as well as the lead of the Space Security and Safety Program at the Robert Strauss Center for International Security and Law. Moriba came to UT Austin by way of the Air Force Research Lab and NASA's JPL prior to that, where he was a spacecraft navigator on a handful of Mars missions. Moriba is a fellow of multiple organizations, from TED to multiple prestigious American and international institutes related to aeronautics, as well as serving on many international boards regarding the safeguarding of the space environment. Moriba, thank you again for joining us. And to begin, could you tell us a little bit about your career up to now? How did you get to where you are?
Yeah, so thank you. Thank everybody for listening in. I would say that I really started getting curious about stuff in space when I was 17, 18 years old. I had graduated from a military high school in Venezuela, came back to the United States, and it was my job to guard nuclear missiles in Montana. So there's a base there, a couple hundred intercontinental ballistic missiles, Minuteman II, Minuteman III systems, and I used to have to pull lots of night shifts. And one of the things about Montana that I had not really experienced, before then, because I grew up in Caracas, Venezuela, big city, lots of lights, is when you're in a place where the skies are very dark, it's amazing to look at the night sky, right? And so during my night shifts, I'd watch the sky and I'd see these dots of light moving across the sky, and I'm like, okay, well that's not a plane. It's too slow to be like a meteor. What are these things? And come to find out, these were human-made objects, anthropogenic objects in space, reflecting sunlight, and it was like, wow, like it was just very amazing for me to have realized that things that humans put in an orbit were reflecting sunlight, and I on the ground was actually seeing this stuff. So I think that really solidified my curiosity in wanting to become an astrodynamicist and study motion of stuff in space.
So you've often used the term space environmentalism. Could you explain a bit more about what you mean by that?
Yeah, absolutely. So I would say that, when I graduated from University of Colorado, I got a job at NASA's Jet Propulsion Lab, and I was pretty much focused on Mars missions. But some years later, I went to Maui to work for the Air Force Research Laboratory, and that's when I became acquainted with all this stuff orbiting the Earth. And I'm like, wow, 26,000 objects orbiting the planet. Only about 3,000 of these things are working. Everything else is garbage. And I just couldn't believe the amount of trash. So maybe this is a great time where I can like share my screen. Can we try that?
Please do, yes.
Okay, so we can try this real quick. And can people see that?
Can do.
I think so.
So this is this thing called Astrograph that we have at the University of Texas at Austin, and basically it's a compendium of multiple sources of information about stuff in space. I'm not even showing like all the stuff that's tracked. Like I haven't even clicked on most of the debris and stuff. And so every dot is an opinion about some human-made object currently being tracked or monitored or whatever in space. And so back to this idea of space environmental type stuff, right, is I became acquainted with this issue of space traffic and all the space garbage. And it seemed to me that we as human beings, the behavior, the unsustainable behavior and ecosystems that we had in the land, the oceans, the atmosphere, climate type stuff, seeing very similar effects and impacts in space. And so that's where I'm like, okay, I'm just going to coin the phrase space environmentalist. And so when I became a TED Fellow in 2019, part of my TED Fellowship was me just kind of going out there to the world and saying, I am a space environmentalist, and really, we should be learning from pockets of humanity that have done quite well in environmental sustainability, like certain indigenous people, like the Inuit, like the Maori, and some others. There's this thing called traditional ecological knowledge, and it's really indigenous knowledge about behaving sustainably and being in balance with life. And not so much owners of things, but more stewards and custodians of things. And I very much resonate with that. And so that's the sort of lens that I use to look at the space garbage, as one of stewardship and custodianship of the environment, and trying to apply this indigenous knowledge to space.
That's fantastic. Thank you. I really like the idea of a stewardship and custodianship approach. And I do recommend to all of our viewers to watch the TED Talk, because it is a fantastic talk. Do you think that you've seen a difference in how there has been a public perception about this issue in the last couple of years?
Yeah, so I think the answer is yes. I'd like to think that maybe some of my effort is helping, raise awareness. Certainly, this project that we have at UT now called Eyes on the Sky is very much focused on this, where we're trying to develop a mixed reality experience to bring groups of people through that mixed reality experience to basically get this awareness. I will say this, right? So it's good to keep in mind that near Earth space is a finite resource, and it needs environmental protection, just like other environments with the Earth. But it's a contested environment, both geopolitically and commercially. And so from the geopolitical perspective, what I've seen over the past few years is saber rattling, right? The US says Russia's doing blah, 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 and China's doing this. China says, so-and-so is doing this to me. Russia's saying this. The Indians are saying this, that. So there's this kind of escalatory behavior that I see. There's definitely, this whole arms race in outer space, which is not good news. And we should do everything possible to prevent that. Not the least of which is trying to make everything known and transparent as a possible deterrent to this sort of thing. But then you have, it's not just geopolitics, but it's also space industry, space commerce. You have companies that are trying to launch massive quantities of satellites for global internet or for Earth observation and these sorts of things. And it's almost like it's a new bonanza, a new gold rush, where companies are trying to, again, put as much hardware on orbit as possible. And even though there are no deeds to orbital space, it is a first come, first serve kind of environment, because physics tells us that two things can't occupy the same space at the same time, or bad things tend to happen. So there's this space race from commercial as well. And so really those are things that we need to take into account.
So speaking about these different issues, which would you say is most important, or what's most important when talking about space sustainability?
So I would say this. First, I think humanity needs to recognize how we're polluting the orbital highways. And given the current pandemic situation, I like to make some analogies to that. We want to flatten the curve on the growth and the spread of orbital debris, orbital garbage. One way to do that is to be compliant with mitigation guidelines that experts and the United Nations Committee on Peaceful Use of Outer Space have put out there. Over 90 countries have signed to these long-term sustainability guidelines. And so the biggest culprit for the growth of the debris is a lack of compliance with these guidelines. Just like you have these, people are just behaving in ways where they're not using the masks, they're not blah, blah, blah. Right. So analogously in space, there are these, hey, if you do these things, it'll help flatten the curve. And lots of people aren't doing that. So that's part of the issue. The other thing too is we have super spreader events in space. And it's not necessarily parties of people getting together, but it's large rocket bodies that have been up there for decades, and they're ticking time bombs. It's not a matter of if, it's when. These things explode or something will collide with the massive rocket bodies. And when large objects explode or collide with something else, they become tens of thousands, hundreds of thousands of smaller pieces now up there almost for perpetuity. And so we need to recover these rocket bodies, right? Now, if you say, okay, well, all right, from a sustainability perspective, can we go up and recover, the top 50 rocket bodies or blah, blah, blah? Who's going to pay for that? Well, the main entities that are liable for those rocket bodies are really the US, Russia, and China. Those are the main. But if you went to the American people and said, okay, here's the thing, right? You have problem with schools, you have problems with water, you have all these other problems, but instead of putting all the resources on that, now we're going to take several $1 billion and we're going to go pull these rocket bodies from space. Nobody's going to go for that, right? Because it's hard to quantify. How is that really hurting me right now? Here's this rocket body. It's just, so part of what I'm trying to do is I don't believe in being an alarmist. That's the wrong thing to do. But I want to be a realist, and I want to tell people, listen, the technologies that you use on a daily basis, position, navigation, timing, banking, even the data that we use to understand climate change and all that comes from space. And more of the technologies that we use on a daily basis are somehow tied to space-based infrastructure. Nothing is protecting these things from harm or damage or loss. And if we don't change our behavior soon, we are certainly going to have a tragedy of the commons in space. That will happen. Because again, finite resource, specific orbital highways, these things are becoming more packed with traffic. And when things die in orbit, they don't stop and just fall down kind of thing. I mean, things are always in state of free fall because that's what an orbit is, but they still move at these very high speeds. And so it's almost like, okay, you're driving on the freeway and all of a sudden your car runs out of gas, but your car still keeps on going at 100 kilometers per hour, and you just jump into another car and just keep on going. So you have all these driverless objects next to you, and it's like all this highway trash moving with you and bumping into each other, and now we got to steer out of the way, and there's nothing protecting the drivers from these collisions. So that's really the state of affairs with stuff in space. Yeah,
and I really appreciate your highlighting the importance of transparency and making sure people are aware, the public is aware. And I think the comparison with a pandemic is fairly apt, not least because I think some have spoken since a couple of decades about this sort of runaway effect where you get more and more orbital pieces colliding with each other, and then that sort of increases slowly the risk of operations. And this has been called Kessler effect. Could you tell us a little bit about this and whether you think that that's going to be something that's going to severely impact things? I know that you want to balance the alarmist approach and the realist approach.
Yeah, so I'm going to start off by saying that I'm not a fan of the Kessler effect or Kessler syndrome kind of thing. What I am, and I'll explain why, what I am a fan of is coming up with a definition for orbital carrying capacity. So the thing is, we have an understanding of carrying capacity from an ecological perspective, right? It's like here's this finite resource, and that finite resource can only sustain so many individuals. And when you have more individuals than that threshold, people start to die, like bad things start to happen, right? Carrying capacity from a highway perspective is like, okay, if the traffic exceeds some threshold, then not so good things are going to happen. Sorry for the dogs in the background. So not so good things are going to happen. So we need to kind of fuse or blend these kind of concepts of carrying capacity and basically say, okay, let's come up with carrying capacity for an orbit. And pragmatically, what we could say is that that carrying capacity of the specific orbital highway is exceeded once our decisions and our actions can no longer prevent collisions from happening or loss of certain services and that sort of thing. Let's say, you know, if our actions can't prevent more than 10% losses per month or whatever, we can come up with that definition. That, I think, is a real thing. That then becomes a sustainability metric. That becomes a basis of talking to an international organization like the ITU. The ITU manages spectrum. Any satellite that you launch, is going to communicate. The ITU says, okay, here's your frequency allocation, your slot for your specific object, right? If we can come up with this carrying capacity definition that everybody accepts, sorry, real quick. The life of pandemic living. If we can come up with this kind of definition of carrying capacity, then maybe an international organization like the ITU, maybe it's the UN, can allocate capacity to people wanting to operate in space, right? And say, okay, you don't own the capacity is leased to you by humanity over so many years. And once you're done with your mission, you have to give the capacity back by removing your object and that sort of stuff. So that's the direction I think we need to go in. This whole Kessler syndrome of things in perpetuity will collide, and then it's this runaway thing where you can't launch anything. It's like Mother Nature always seeks equilibrium. At some point, things become so small and relative speed so small that it's not this infinite kind of thing. I think that's the thing that I don't like about the Kessler syndrome, is that people just think about it, say, okay, things are going to be infinitely colliding, and then you're going to have like this cloud like Saturnian rings, and you're not going to be able, it's like, maybe we shouldn't go there. But certainly the carrying capacity is something that's inarguable and makes a lot of sense.
So talking about this carrying capacity and the different regulations that are in place, could we quickly go through the different regulations that already exist, and what do you think are missing regulations and what we should further implement?
Yes, I will say this, right? Some people, it's a very good question. Some people talk about, do we need new space laws and that sort of stuff? I think we just need to use the ones that are already ratified, already in place, and we just need to be better at that. When I look at things like the Outer Space Treaty, for instance, ratified by over 100 countries, I look at things like Article 6 of the Outer Space Treaty that say, okay, nation states have the responsibility of providing authorization and continuing supervision of all activities of non-state actors. Well, what does continuing supervision mean? Does that mean that people that they're authorizing aren't doing things that they're unaware of on orbit? So I think that doing a better job at first understanding how we interpret the current laws, policies, and regulations, and then do a better job harmonizing that across humanity, I think is good. I think that knowledge about stuff in space, because most of it is scientific, is more common, but the practice, how we practice behavior in space, is very individualized, and I think that's part of the problem. So, when I look at Outer Space Treaty, when I look at the United Nations Convention on Registry of Space Objects, I got to tell you, for instance, with Space Object Registry, it says that launch states are responsible for registering their object with the UN as soon as is practicable. As soon as is practicable. So when I look at, I'm going to share my screen again, because this is going to be, I think this is going to be an interesting thing to see. Hopefully people can see this. So here we go. We put together this website for compliance, and here we're just looking at objects registered with the UN in 2019. So I'm going to click on that. We'll see what happens here. It's basically querying our AstroGraph database. It's pulling some of the UN information that we have scraped off the UN website and their PDFs and all that stuff, and is putting all that together. But yeah, so here we go. These are the objects registered with the UN, in 2019. So you can kind of see where those are at. But what I want to show you is if I click here for view the tabular results, you're going to see something interesting pop up here. And what that's going to show is it's going to show, which countries registered, objects and how long it took. So here we go. Here's a state of here's a registering state like France, United Kingdom, blah, 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 where it says lag data. So that's number of days between when the thing was launched and when it was registered at, submitted to the UN. Just to calibrate people, right? 365 days is a year. So, 1,916 days is a while to submit the. So when people say as soon as it's practicable, really, as soon as it's practicable means like 5 years, more than that. Okay, this is nice. 9 days later, that's great. That's I think that makes sense. 7,000 days after. Why is it taking so long? So I think we need to do a better job with understanding how people are implementing the current things that they signed up to do, and then saying, you know what, when we said as soon as it's practicable, we really didn't mean 5 years later. We kind of meant maybe within a few weeks. Can we all just agree to do something more like that? So that's what I think needs to happen. Not necessarily create more laws and policies, but look at how people are implementing what's currently in place, and then as an international community, come to some agreement on norms of behavior that lead to greater sustainability.
Yeah, absolutely. On this subject of registering objects and making sure that we're all aware of what's going on and following international regulations, there is increasingly a sort of comparison made between the old space activities and the so-called new space, where we're seeing a lot more independent activities from private companies launching things on private launchers for private clients. How does this affect space sustainability, especially from a regulation point of view? We do have a viewer asking what's SpaceX in particular doing about this?
Yeah, so I will say this, right? People are behaving in ways that are legal. So the thing is, if the legal stuff is something that you can kind of drive a truck through, it's so broad in its interpretation, that sort of stuff, people tend to do the race towards the bottom. What's the least amount of stuff that I can do that still keeps me out of any sort of legal issues, and because you have stakeholders and people wanting to make profit and all this other stuff. So these are bottom line things. I will say that some commercial space companies are very forward leaning with wanting to behave sustainably, and yeah, I mean, I'll even say that for instance, the astronomy community was not so happy with SpaceX, right? Because the astronomy community is like, oh, we have all these objects that are reflecting sunlight towards our ground-based telescopes, and they're corrupting our images. And in fact, what I'm gonna do here is I'm going to find. So one of the things that we did with the astronomy community, with the International Astronomical Union and American Astronomical Society, is we participated in a study on this sort of thing, and we developed this tool that helps predict what the light pollution is from sunlight reflecting from these anthropogenic objects in space. And I'm going to find you one of these. It's amazing. Okay, this thing. It's fairly unbelievable to see the amount of stuff up there. Let me see if I can find this real quick. And here we go. I'm going to, okay. So I'm going to share my screen again. hold on a second. Let me try to do this. Okay. So hopefully people can see this. Yeah. So what I'm going to show is this, right? What you're going to, so this is predicted for LSST, which is down in Chile. And what you're seeing here is all the streaks are the currently tracked, like 20 some odd objects, anthropogenic space objects, that would be going overhead at this site in Chile on this day. And the streaks are light reflected from that. It's all in visual magnitude. Humans can see down to about 6. Larger numbers are dimmer. Clearly, astronomical stuff can see fairly dim, but this kind of just gives you an idea. So this is as if you were standing at the site looking directly up and then north, west, south, east kind of thing. This one is, you know, the celestial sphere, a sphere around the Earth as a whole, and in the direction of, you know, where the site is. So you're going to see a bunch of stuff here. The yellow dot is the location of the sun, and the gray dot, the location of the moon. This subplot here is if you were the telescope itself, the gray area is below the horizon. The telescope can't see that. So this is like, you know, the field of regard of the telescope. And then these fields right here, these Messier objects, these are locations in the sky that astronomers care about for their astronomical purposes. And again, each streak is one of these human-made objects, anthropogenic space objects. All right, so I'm just going to play this movie. It starts at dusk, and you can kind of see this is the clutter that astronomers have to deal with every single night, not getting better. That's a lot of stuff. Each one of those streaks are things that are unwanted in the field of view because they want to see natural objects and natural phenomena, not, you know, human-made stuff reflecting, you know, sunlight. And so you're going to see as the night progresses, things become a little bit better because a lot of these objects are going through Earth eclipse, you know, through umbra and penumbra, so they're not reflecting as much sunlight as you know, but you can see higher altitude things are. And you know, as dawn, as we reach dawn, you're going to see the swarm of reflective stuff show up again. So all the objects are still there; they're just not reflecting sunlight because of eclipse periods and that sort of stuff. But it kind of gives you an idea. This is the stuff that people have to deal with on a nightly basis. And so, you know, back to SpaceX, they actually have done some tests, have launched objects, and operated in a way to try to minimize the negative impact to astronomy from reflections, you know, solar reflections off of their objects to, you know, ground-based observers. So SpaceX has done that. You know, other companies are certainly looking at what can they do to be more helpful with the way they operate their satellites, to minimize impacts and these sorts of things. So, but again, most folks are just focusing on, you know, what's legal, and I'm just going to kind of just, as long as I'm legal, then I'm good. And so there are companies, space companies, you know, startups and that sort of stuff, where their line of sight exit strategy is 5 years, and they don't necessarily understand the domain. They don't necessarily care. They just want to do something really cool, make lots of money, and then get out of it, right? And so I would say those folks are less concerned about space environmentalism. So.
So do you think, especially with new space, where we should introduce new incentives for companies to stick more to the regulations already in place?
Yeah, and so you know, the World Economic Forum started this path looking at developing something called a space sustainability rating, which is kind of like, you know, when you go to a restaurant or hotel, the 5-star kind of thing, whatever. And you know, hopefully, you know, with this rating, companies would be incentivized and launchers would be incentivized to try to maximize this rating. And then there's a certain set of behaviors that they could pursue, which would give them a higher rating than other behaviors and that sort of thing. So I think it's, you know, moving into phase 2. This space sustainability rating from the World Economic Forum is moving into phase 2, and currently looking for folks to want to adopt, to host it and run it and that sort of thing. So hopefully that'll continue to progress.
Fantastic, thank you. And when you know, once we measure these things and have a better understanding of who's playing by the rules and so on and so forth, how would you then balance the mitigation measures between having, let's say, cleared orbits for particular things, having that sort of ITU approach where certain bands have been allowed, or trying to go for mitigation measures, having end-of-life strategies where at the end of, let's say, a 5-year period, you can deorbit burn, etc. What do you think is one of the best ways to do this?
I think the domain is, textbook definition of a complex system. I think there's a lot that we don't understand. Small things have very nonlinear and large consequences. I'm definitely a butterfly effect kind of a dude. But I think that we don't really understand what are the butterfly effect kind of things going on in space. And so I think I want to just like with the whole pandemic, letting science figure things out, I want for science to help us figure things out in the domain. And I think that once we start understanding causal relationships and where the butterfly effects are and these sorts of things, it'll make sense for us to have like evidence-based policies, regulations, and behaviors as a consequence of that. But I think we need to invest and allow science to inform us of really trying to understand this complex system a bit more, before we can kind of take those things. And I will say this, just like on Earth we try to minimize single-use plastics. I would advocate for minimizing single-use satellites. So when we design a satellite, let's design it with the intent for it to be able to maybe be recycled, repurposed, these sorts of things.
And so do you also think there should be more international agreements with countries becoming more active in the space industry, especially?
So can you say it? So can you repeat that?
Yeah, so do you think we should also introduce more international agreements between countries and to deal with these different kind of issues?
Well, so, certainly some countries try to do a little bit of that. And I've even seen some companies try to do that we're the consortium of the best practices and we're the blah, blah, blah. And we're going to come up with join our team. And I just think that is less useful because whatever countries didn't come up with that idea or didn't sign on at first are now kind of like anathema. And I don't think that these are unifying things. I think that all these things serve to be more divisive than anything else. It's like, look, we have a United Nations. We have an Office of Outer Space Affairs. We have Outer Space Treaty. We have lots of stuff already. Like, let's work with the current tools and mechanisms and improve what we already have versus come up with more stuff. Like, anytime I see, Amberland or Acme Incorporated come up with one more thing of, we're gonna call ourselves the International Space Sustainability, blah blah blah, and here's our manifesto, join blah blah blah. It's like it's just one more differentiator, one more thing that fractionates, one more. It's like you got it all wrong. Look at what we currently have, and the thing is, things that we currently have don't work better because in great part is just it's effort. It's joint effort. It's like if all of us believe in this stuff, we can come together and improve the utility of what we've already fought hard to sign off to and put in place.
I very much appreciate the international outlook, the cooperative outlook. One of the things that's recently come about, somewhat maybe in contrast, is these Artemis Accords, where there is some clause of space sustainability, a specific mention about space debris as well. in addition to the comments that you made before about trying to build on particularly the UN system, I suppose, do you think there's anything else that's missing from that?
From the Artemis Accords? I mean, here's the thing, right? There's nothing new there, man. The Artemis Accords are all like a regurgitation of all this other stuff that happened before. It's like there's nothing new there, you know? So it's an example of, I don't think we needed that. That's just one more thing that's a distraction, right, from coming together. So I just think, I mean, like one of the interesting things that I saw in the Artemis Accords was this whole thing about respecting the Apollo stuff. Yeah, that's like, yes, that's very important to Americans, right? Not basically tampering with any of the moon buggies from our Apollo missions or the footprints of certain astronauts. It's like, I think cultural heritage needs to be honored and respected in space exploration. But yeah, I mean, you know, if we go to Mars right now, what are we going to find? We'll find a couple of rovers that maybe are working. We'll find some other stuff that isn't. We're going to find some parachutes flapping in the Martian wind. We're going to find some burnt heat shields scattered like debris. We're behaving the same dumb way with exploration, right? It's like, oh, well, whenever the thing stops working, we're just going to call it a monument. No, that's trash, man. It's garbage. Really, the monument, the statue, so I just think we need to do things differently. I do think that one nation's treasure is another nation's trash, and we need to be very respectful, cognizant. We just need to have an inclusive dialogue about this stuff. Instead of just doing things because we can, we should think about doing things that we should. And when I say inclusive dialogue, for me, inclusivity is when diversity has a vote, when diversity has a voice. So to me, a group of people that are diverse, but only 3 people get to actually say what happens, that's not inclusivity. Let's have an inclusive dialogue. And I can tell they're already like space companies like, okay, well, why should I talk to the people from Zimbabwe about my space mission when they don't contribute, blah, 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 blah? Because they're humans, because it's the heritage of humankind, because it's the right thing to do. I'm not saying uniquely let people from Zimbabwe, basically tank your mission, but just ask them how they feel about the fact that you're changing their night sky. How do they feel about that? Like, have you just even asked them that question? That's the thing. I want people to take a moment of pause and just consider the opinions and the feelings and the cultural nuances of the rest of humanity just before you just go out there and decide you're just going to be this trailblazer and blah, blah, blah. I see this stuff with like Elon. Oh, I'm just selling all my stuff and show people that I'm going to go and like colonize Mars. First of all, that term colonize is like complete bollocks. Like, that's crazy, right? Like, we should not be using these terms, colonize, right? Because it's very insensitive to, I don't know, groups of us who within our own ascendancy have colonization as like a not so good thing. So these are the things that I'm talking about. It's not just a scientific endeavor. It's a humanitarian, it's a sociological, anthropological endeavor. Anyway.
So going more now into the engineering or technical side, do you have any ideas of what the latest technologies are which help to mitigate space debris, or of any new technologies which are currently being developed?
Yeah, it all comes from the fishing industry, right? Nets, harpoons. So these are all like the humanity's greatest technologies to remove space debris all come from fishing. I think that there's more that we need to do in that endeavor. Clearly, people want to have businesses of debris removal. I think that there's no money in that sort of thing because we haven't come up with the sustainability metrics, right? Like a space traffic footprint that could be a carbon footprint analog showing the impact that any given object has as a burden on the safety and sustainability of other things, the whole carrying capacity. Like once we can come up with orbital carrying capacity, space traffic footprint, then it's like, okay, now we can advance this technology because I want you to remove that. Well, why do you want me to remove that? Well, because it has this footprint, and if you remove it, it's going to give this much capacity back to that orbit. Now we're talking in a way that makes sense and is monetizable. But just like, oh, I'm just going to develop this just because I can do it. It's like, what's driving that? At the end of the day, people need to make money, and money drives a lot of you know, what it is that we do. So.
Yeah, fantastic. Going further on to this, I mean, we've spoken a little bit about technologies for debris removal, as you say, from the fishing side of things. I've heard some contrast made between stuff that's in low Earth orbit, which is more amenable towards catching, and stuff that's at a very much higher orbit, which is much more difficult to get to. As far as I understand, the classic approach here is to move things to a graveyard orbit when you can't deorbit them entirely. What do you think about this particular approach? Do you think that this is something that's in any way a long-term, or is a very short-term solution?
It can't be the right answer, because basically it's the equivalent of a landfill in space. That's what we're doing. So, you know, the current graveyard will never. So that's another thing that we need to realize. First of all, we need to embrace the fact that we have to live within our own filth for perpetuity. So we don't have a clean bathtub. We just need to make sure that we're not dirtying it more. And so the current graveyard, we'll never clean it, but let's start relooking at this and try to find ways of not doing this graveyard thing anymore. Because again, it's like a landfill equivalent in space, and I just think it's long-term unsustainable. And so back to the whole single-use satellite stuff, minimizing that, it's like, if we design things that go to geo, that can be repurposed, that can be recycled, these sorts of things, at least that's helpful.
And so talking more about, because we can't remove all of these things, what do you think about the new mega constellations, which are set to go into space soon? Yeah,
I mean, so all those are that I've seen proposed are all LEO at different orbital altitudes. I think that they need to be, you know, designed for demise, and how these things can be removed so that, you know, capacity is you know, given back to these orbital highways. I think designing these things, again, with the idea of repurposing and recycling would make a lot of sense. And I think the other thing too is coming to a common understanding of what are the decision criteria for moving out of the way and that sort of stuff, like coming up with some sort of agreement on traffic rules. I think that needs to happen for sure.
Fantastic, thank you. And I'm just going to jump on with a question from our audience, from Sarah Wigmeyer, who also thanks you for the great point on diverse voices critically needing to have a vote. Do you have a sense of the order of magnitude of how much easier or harder it is to remove space debris versus, let's say, microplastics from the ocean?
You know, interestingly enough, I think that's a great question. So there are a couple of women that I've been chatting with probably for the past you know, year or so, and I'm just kind of yeah. So one of them, her name is Imogen Napper, and she's at Plymouth there in the UK, and you know, there's also another person, Heather Caldway, and she so both of these women are Nat Geo fellows and that sort of stuff, and they are looking at anthropogenic ocean objects microplastics and whatnot. And the similarities are uncanny between the two. And in fact, we were looking at doing a joint proposal together to try to unify ocean debris and space debris research. But yeah, in the sense that microplastics, there's just an uncleanable set of these things in the ocean. There's an uncleanable set of stuff in space. And again, the similarities are uncanny between ocean debris and space debris.
Maybe just going back to space constellations, I've read that currently about 10% of the satellites we send do not work. Given this, what do you think of this issue, and do you think there is a way to remedy that?
No. So the thing is, in all things, there's some level of risk. And if we pushed for satellites to have 100% success, we wouldn't have space industry anymore. Because the amount of work and all that would have to go into this would be so economically unfeasible that there'd be no way to do that. Same thing with space exploration, right? I mean, when we think about humanity extending back to the moon and beyond to Mars, we have to accept that there's going to be a certain percentage of people that are going to die in that process. And if we're intolerant to that, then there's no exploration. So unfortunately, we have to live with that percentage of things that just won't work. And that has to be part of our calculus when we talk about sustainability, is assume that there's this percentage of things that just are going to be dead on arrival kind of thing. And so how does that influence our behavior when we're trying to put so many objects on orbit? That has to be part of it.
That's fantastic. And this is actually something that I wanted to ask as well, which is this notion about the risk aversion and about exploration as being a dangerous affair. I wondered if you could talk a bit more about this. What's changed in, let's say, the last 150 years, or what should be changed as we move forward?
Yeah, so here's the thing, right? When I look at historically looking at exploration, dying was something that was like embraced as this is part of the way things are done. We're gonna go in this boat, we're gonna sail, and some boats are just gonna sink with everybody on them, and some people are just gonna get sick and diseased. Even crossing from the East Coast to the West Coast of the United States, kind of same thing. It's like we have become, well, for one, especially here in the United States, I look at the money that the Department of Defense gets versus like NASA to do this stuff. It's like NASA's budget is minuscule compared to defense. And yet everybody, not everybody, but many people, right, basically are completely risk intolerant of NASA. It's like, hey, if you're going to launch someone in a space and something bad happens, then that's pretty much going to ground your fleet. We should kill the space program, blah, blah, blah. It's like, really? You haven't understood, you completely missed the boat on exploration. No, in fact, we need to take risks, calculated smart risks, but risks nonetheless. And if you want NASA, I think one of the things that's hindered NASA so much is this risk intolerance. And so it's when I worked at JPL, it was like, wow, if you have a Mars mission that fails, I mean, not only do you feel bad about it, but you have all these people, these taxpayers saying, you see, all these people at NASA's Jet Propulsion Laboratory, we should like just close the doors because this rover failed. It's like, it's a miracle the thing worked. People just don't realize how complicated all this stuff kind of is. And we try to make it, space is like this routine thing, and it just doesn't have these risks. And whenever something bad happens, it's because of incompetence. No. the fact that more bad things don't happen is because we're so awesome at it, you know? Because the thing is just it's ripe with things that can go wrong. And so because of that, whenever NASA does stuff, it's like, well, use the success from before, and the next mission is just incrementally better, right? Because you're trying to minimize that risk. Like NASA has stopped doing the really bold things, in my opinion, because, you know, of the risk and the intolerance. And so then you have commercial companies like the SpaceX's and blah, 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 that kind of like do this belly laugh at NASA. Oh, you know, we can do what you do better and cheaper. It's like, where did you learn rocketry and all that stuff from? It came because NASA retired risk. It was because at the beginning, we did lose people and we did take bold moves. That resulted in risk retirement that now you get to enjoy and make lots of money from. So I would hold the belly laughing, and I would look at things like NASA, and I would try to give them latitude and agency to take bold risks, trusting that they're clearly doing it in a very responsible way, as responsible as possible. But it's like, accept that there's going to be losses and significant ones, but the payoff from these will be to significantly advance the science and technology and all these things that humanity will get to enjoy as a consequence of that risk taking.
So we have another question from the audience. In one of your previous images, there were a number of orbits that were for more densely populated than other regions. And the question is, what measures could be taken to avoid to populate these regions more?
So I think that's great. I think one of them is, back to this idea of carrying capacity. If we can start quantifying that, then we can say, yeah, the capacity in this orbital highway is saturated. So no more licenses for people to launch into this orbit or whatever, right? But in the absence of that sustainability metric, it becomes difficult to try to apply that or incentivize people.
Fantastic. That's great. So, many of our members and those in the audience are keen to work in the space sector, and we have seen an enormous growth, and of course, all this exciting topics of discussion that really need to be had. So what piece of advice would you give someone who might be in the audience and a student?
I would say this. One person can make a significant change. So believe in yourself. Don't let other people's opinion become your reality. I got told no a lot during my own trajectory. I wasn't good enough. I wasn't smart enough. I wasn't blah, blah, blah. Consider that noise, and just there's hard work, but basically it's in your hands. And the way that people did things before, you are more global, you're more international, you see more of these kind of effects. The long-term sustainability of humanity as a species is basically in your hands, and humanity has an expiration date for sure. If we don't leave this planet to learn how to live elsewhere, we don't extend our expiration date. So let's work on extending our expiration date as a humanity, but it can't be with the same mentality that happened back in the Crusades and all this other stuff, right? We need to do things differently. We need to realize that we're more similar than we are different, but our differences are kind of cool, and we should celebrate, respect, and honor these things. We should realize that everything's interconnected in one way, shape, or another, right? And so this is what I would say. Please use that as your basis, and try to act from a place of compassion. Use this as a basis as you go forward. We need more of that in the space industry. We need less lovers of idolaters of like astronauts and stuff like that. These are just people. Are they cool people? Yeah. but they don't need to be idolized and all this. I see people in space, it's all about the groupies. Oh, you know, it's just this astronaut, this other thing, that blah, blah, blah. It's like, we don't worship people that fly us on a plane from one place to the other. We don't worship people that drive boats across the ocean. We shouldn't worship people that go into space. Space is just an extension of humanity's sphere of influence and activity. So let's normalize that. Let's get rid of the elitism and that sort of stuff. And let's enroll the rest of humanity in this vision of space exploration.
That was very interesting. Thank you. I think, unfortunately, this is all the time we had for today, but thank you very much for your answers. Do you have any closing remarks or any final statements you want to say to the audience?
You know, thanks for giving me some time to, I guess, engage with people, to share some of my thoughts, opinions, and experiences, you know, so far in some of this. And yes, the time goes by quickly. I really can't underscore enough this feeling of wanting to, you know, express to everybody this idea of really honoring, respecting this interconnectedness of things, acting from a place of compassion. We need more of that.
Moriba, thank you for ending on such a hopeful note. Thank you again for joining us.
Thank you very much.
I think that concludes the end of the stream. I think we